Okay, we have a few questions. Maybe we can take them.
Okay.
Rachel.
Masayo and Dr. Ibrahim. I do understand the cumulative incidence, but I have like a confusion here. So for instance, if you are measuring cumulative incidence, is it possible for people to be at risk of something and after a while they are not at risk anymore? And then do we exclude those people from the number of individuals at risk at the time C0? Because, you know, like you said, cumulative incidence is the number of new cases over a period of time. So is it just those that are at risk at time 0 we are considering, or those that are at risk at that point, should I say, for that period?
Yeah, so I mean, that's an important observation. The short answer to that is that individuals at risk at T0 is what is going to be realistic. So for instance, if we're saying we want to calculate the cumulative incidence of COVID in Lagos from January 1st, 2022 to June 1st, 2022, the denominator is not everybody who's in Lagos on January 1st. I mean, because there are going to be people who are vaccinated. Let's assume for this purpose that vaccination confers complete immunity, or those who've just recovered. But that is what it is. The question you're asking is, well, do we recompute? Do we also recompute on February 1st and say how many people still remain? Susceptible at this point? No. The denominator is how many people remain at risk, meaning that how many people are not vaccinated, did not just recover, and therefore are at risk of COVID as of January 1st. That's the classical definition.
Okay, let's take questions while we wait for Dr. Motayo. If I have a question, can you unmute yourself, please? Yeah.
Okay, yeah, I do. Thank you. So my question is this. Dr. Motayo made mention of say a subject like subject X had COVID in December 2021.
Yeah.
But then it's still counted as a prevalence case, like the total number of cases within January 2022 through June 2022. So why is this still counted? Because if I receive a data like that, and the person gives me data that is obviously within January to June 2022, and I see a case December 2021, I'll flag it as red because it's not supposed to be within the data. So my question is, why are we still counting it? Yes, it happened last year. He has not survived, but then it's still not within the prevalent cases within January to June. I don't know whether you understand my question.
I understand your question. So the concept of so I think one of the things that causes problem is the disease causes problems with the understanding of this thing is that the disease itself affects how you understand prevalent cases. Now, for a prevalent case, right, it's a case that the person continues to have during the period under consideration, right? So for something like COVID, if the person was diagnosed with COVID in December and continues to have COVID until January 2022, right? Then that is a prevalent case in January 2022. It was not a new case in January 2022 because it was a new case in December, okay? But because that person continued to have COVID in January 2022, so then that person is a prevalent case. So the idea of a prevalent case versus an incident case is that the incident case is new and the prevalent case is old plus new. Now, the thing with COVID is that because it's a disease that people typically have it, most people will have it for a few days to a few weeks and then they'll get better, right? Because of that, the nature of that disease, you have to be careful as to when are you looking at prevalent cases in January versus are you looking at prevalent cases, you know, like you have to be careful of when you're drawing the line. So if you're looking at prevalent cases in January, this person may qualify, right? But if it was a condition like a cancer, then the prevalent cases might, like you might have a person be a prevalent case for more than a year, because of the nature of the disease. So that's important to kind of tease apart, that the nature of the disease also affects how we think about the prevalent cases versus incident cases. Yes, please go ahead, Dr. Matara.
Okay, now can we move to the next slide actually?
Okay.
I think we're done with proportions. So now that we understand what a ratio is and we understand what a proportion is, a rate is a lot easier to understand because a rate is just like a ratio. The only difference here is that the denominator here is a time measure. So we're comparing two things, but the first thing we're comparing is actually a particular entity, maybe number of cases, number of people, number of doctors, number of adults, number of children. But what we're measuring, the denominator is a time unit over a period of time. And I won't take so much of the time here. Like I said, the reason why we talk about these concepts is that when we get to things like regression models, when we get to other kinds of analysis, when we get to things like classification, for instance, the way we think about what is appropriate to do and what is not appropriate to do depends on whether the measure that is of interest here is a ratio, or it's a proportion, or it's a rate. These distinctions have implications for what kind of models are valid, what kind of models will be compatible with the kind of inferences that we're interested in drawing. So the incidence rate is one of the commonest rate measures that we will encounter in published papers in clinical medicine or in public health or in epidemiology. And that's essentially the number of new cases that are in the study, as the number of new cases during the period of time of interest as the numerator, and the denominator is the total number of time spent in the study by participants. And here's the reason why this is important in a bit. Say we're interested in incidence of a disease, for instance. Let's say we're interested in incidence of HIV/AIDS, for instance, from January 1st to June, from January 1st to June 1st in 2022. Now, if what you get, well, I think that for the purpose of this class, what is most important is for us to know that, an incidence rate is the number of new cases during that period, and the denominator is the number of total time spent by participants. That is the way that is different from the total number of people in the population, is that there will be participants who would participate. This is important in studies where participants would have variable contributions to time contributions to the study, meaning that some participants would be there from the beginning of the study till the end of the study, meaning that they were at risk of getting the disease throughout the period. Some participants would be there on January 1st, January 2nd, and January 3rd, and then they're either dead or they develop immunity or they're no more in the study area. Therefore, even though we're looking at a study from January 1st to June 1st, this participant is contributing just 3 days in this period. Whereas you have a study where you have 20 participants, and each of the 20 participants were there from June 1st until from January 1st to June 1st. Is different from the amount of risk that is in that study population is different from this, the study population where you have 20 people, but in the first week of January, 10 of them had already left, or 10 of them had already died, or 10 of them already gotten the vaccine and become immune. And then you have the remaining 10, not being at risk again by the end of February. Even though your study, you're looking at January 1st to June 1st, the amount of time at which people remain susceptible during this study is different. Therefore, the risk, the risk calculus in this study is different from the study I earlier described. So the incidence rate is a measure that takes into consideration that even though you're looking at incidence from one time point to another time point, because people can come in, can become susceptible and lose susceptibility over time. During this period, they're not contributing equal risk time to this study. And that's how the incidence rate takes care of this. And that's how it's different from the cumulative incidence. Next slide. So essentially, like I mentioned earlier, the whole essence of this whole enterprise is for us to be able to do three things. One, sometimes look at our population and try to describe it in a way that's accurate and meaningful. Sometimes what we're trying to do is to say, well, can we put together a statistical model